Have you ever noticed the wires that bring electric current into your home? If you could follow those wires back to the place where they start, you'd find yourself at a power plant, a place where electric current is produced. The machines which produce electric current are called generators. As the generators turn, electric current flows through the wires to your home and to all the other places which are being supplied with electric current. Inside your home, the wires pass through the walls to places where the electric current will be used. Electric current is always ready, but it doesn't flow until it is actually in use. It's much like the water in your home. It too is always ready, but it doesn't flow until you turn on the faucet. To learn why this is so, let's do some experiments with electric current. Since regular house current is dangerous, we'll experiment with the current from dry cells, like this one. This current is too small to be dangerous. Here we have connected 4 dry cells to a light with copper wire. We find that the light is on. We have formed an electric circuit, that is a pathway for the flow of electric current from its source, through the light, and back to its source. There are many kinds of electric circuits, but all require one or more devices to be operated, a source of current, and a complete pathway for its flow. Whenever we break this pathway, the current stops flowing. The circuit is then called an open circuit. A complete pathway is called a closed circuit. By opening and closing the circuit, we can turn the light off and on. A switch is a device that opens and closes a circuit. The electric circuits in your home are protected by fuses. This type of fuse is made with a special wire which melts when too much current flows through it. Watch closely and you'll see the wire melt. This is what we mean when we say that a fuse blows. Now the circuit is no longer complete and the current stops flowing. Electric current flows easily through copper wire and some other metals. These are called conductors. But electric current does not flow through some materials like this glass rod. So when glass replaces part of the copper wire in the circuit, the light does not go on. We do not have a complete circuit. Materials such as glass, which stop the flow of electric current, are called insulators. Some common insulators are the rubber covering around copper wire, plastics, and porcelain. There are still other materials, like the wire inside this light, that do not stop the flow of current altogether, but neither are they good conductors. They are said to resist the flow of current. Such resistance causes the wire to heat, and this produces light. Wires which resist electric current may also be used to produce heat for useful purposes. For example, to heat electric irons, toasters, electric blankets, and other electrical appliances. Now let's consider a third important use of electric current. This nail has no special effect on these tacks. Now let's wrap some insulated wire around the nail. As long as the wire is not connected to a source of electric current, the nail still has no effect on the tacks. But when we connect the ends of the wire to a dry cell, current flows through the wire. And now we find that the nail does pick up the tacks. It has become a magnet. The more turns of a wire we wrap around the nail, the stronger the magnet becomes. As soon as we open the circuit, current no longer flows through the wire, and the nail stops being a magnet. This kind of magnet made by the use of electricity is called an electromagnet. Electromagnets are used in nearly all electrical devices that make things move. In this electric bell, for instance, electromagnets help move the hammer that strikes the gong. Electromagnets also operate motors, so our experiments show that electric current may produce light, heat, and motion. In this film, we have seen that electric current flows whenever we complete or close an electric circuit. A closed circuit provides a complete pathway from the source of the electric current through the device being operated and back to the source. This is true whether the source is a dry cell or a generator in a power plant. Breaking this pathway, as a switch does, stops the flow of electric current. Electric current flows easily through some materials and not at all through some others. While still other materials resist the flow of electric current and produce light and heat. Besides light and heat, electric current may also be used to make electromagnets, and nearly all the uses of electricity to make things move depend on electromagnets. These are some of the fundamental facts about electric current, one of man's most useful servants.